Okay, so what we're going to do now is parametric equations. Okay, I'm going to do this with the textbook. Okay, when we are doing parametrics, all we are doing is getting a parameter that links the x and links the y. Okay, so just have a look here, right? If you've got a Cartesian equation is something we can put on the Cartesian plane. Okay, it's usually like y equals mx plus b, y equals x squared plus y squared equals r squared, like anything that's y equals x. Is that okay? All right. What we do with a parametric equation is we make the x part and the y part equal to t. We use some other parameter, okay, to link them, okay? And the reason why we do that, in physics, for example, we do it because t can stand for time, okay? So we can actually link the position on the Cartesian plane in terms of its x value and y value separately in terms of time, okay? So let's just have a look here. We can choose anything to be the parameter, okay? So let's have a look here. We've got y equals 3x plus 1, okay? Now, we just choose a parameter. We just choose it. You can choose any parameter you want. So let's have a look at the first bit. Let x equal p. Okay, if x equals p, then for the equation y equals 3x plus 1, then when we replace x with p, it becomes 3p plus 1. Okay, so what we decided was, we decided that x equals p, and we decided that y equals 3p plus 1. Now, we can write this equation now in terms of p if we like. We can say p equals x, okay, and p equals whatever it comes out to when I rearrange that for p, okay. Let's have a look at the second one. The second one, b, says let x equal p minus 5. So instead of choosing p as the parameter, we're just saying the parameter we're going to choose is p minus 5. So then the same thing happens again. Where I've got y equals 3x plus 1, I'm going to put in p minus 5 into the x value for the equation. And so there it is, okay? So I've got this equation now set up. Instead of y equals 3x plus 1, I've got it as two separate equations in terms of p, some other parameter. That is, x equals p minus 5 and y equals 3p minus 14, okay? The purpose of showing you this one is just so that you know I can choose anything as the parameter. Here's what you actually need to be able to do, okay? All right. So here I've got two equations. I've got, find the Cartesian equation of x equals 3t, here the parameter is t, 3t plus 1, and y equals 2t minus 3, okay? Now, to solve any parametric equation into a Cartesian equation, the golden rule, you've heard me say this before, is eliminate the t's. You have to eliminate the t's, okay? Now the way you do it is like this. You choose one equation, say the x equation, and what you do is you solve it for t. So there's the x equation, and here you can see that it's been solved for t. Does that make sense? Okay? So once we know what t equals in terms of x, then all we do is we put that into the y equation for t. See where the arrow is pointing? So what I do is I get that, x minus 1 on 3, and I put it into the y equation for t. And here it is here. Okay? So now we just continue solving, and we end up with an equation in general form in terms of x and y. So I've eliminated the parameter. Okay? So just quickly, the process again is this. You want to eliminate the t's. Okay? So rearrange one of the equations so that you make the t the subject. Once you've made t the subject, then substitute it into the other equation. Okay? And then just solve so it's in terms of x and y. Okay? Here's another one. Find the Cartesian equation of x equals 2q, y equals q squared minus 3. So let's have a look again and see if the process is the same. Okay, x equals 2q. Okay, let's look at that equation. Let's get it in terms of q. So q equals x on 2. So that x on 2 there, I'm going to put that in for q in the y equation. All right. So let's have a look if that's been done. Yes, there it is. X on 2 squared minus 3. Then continue until you end up with an equation in terms of y and x. Okay? Nothing to it. Nothing to it. Okay? So if you probably noticed that's an x squared equals 4ay equation. Okay? Here's what we do for parabolas. For parabolas, we specifically choose these parameters in terms of t. So we specifically choose for a parabola x equals 2at and y equals at squared. We specifically choose them because they both work. Okay? So if you have a look at the proof, when you substitute 2at in, we end up with y equals at squared. Okay? And we know that at squared is actually y, so y equals y. I don't know if you can see that. Y equals at squared. So when you put the x substitution in, you get the result that is the other parameter. So that's the proof for why they work. Okay? I'll do a bit more of that later. Okay? Alright? So basically what you need to know is this. For any of the locus parabolas we have, we can choose the parameters for x as 2at and for y as at squared. That's what we're always going to choose. Okay? So if we go through and look at the other general forms of the parabola, if I've got x squared equals minus 4ay, then I'm going to choose x equals 2at and y equals minus at squared. Now that result happens because when you put 2at in, you get minus at squared. Have a look. You put 2at in, you get minus at squared. Is that okay? So it's pretty obvious what the signs are for the other parabolas, right? Whether it's sideways parabola, happy parabola, sad parabola, or sideways the other way, if you know what I mean. Okay, so same again there, if the parabola's y squared equals 4ax, so the parameters interchange. The y becomes 2at, and the x becomes at squared, okay? Now this is in your notes, guys. It's in your notes, okay? So if it's a sideways parabola, you just flip them around. Okay, so we'll just continue through quickly. I'm not going to waste time on the proofs, but here's the type of question you could get, okay? So, given the parabola x equals 4t and y equals 2t squared, find its Cartesian equation. So you'll notice you've been told that this is a parabola, but you've been told it's a parabola in terms of its parameters. It's in terms of the t's or t, okay? So the parameter they've chosen here is t, okay? Now, for x equals 4t, okay, we know that t equals x on 4, sorry. Okay? So we're doing that same process again. Let's find out what the t is in terms of x and then substitute it into the y. Okay? So we know that t equals x on 4. So I'm going to substitute that t in to the y. See that? For t squared. Does that make sense? It's the same process every time. Okay, have a look. Substitute in a y equals 2t squared. I've put the x on 4 in and there we are. So what we found here is that y equals x squared on 8. So x squared equals 8y. Okay? Now that's the locus form, if you like. That's what we've been calling it, of the parabola. Okay? So is there any problems with that? We're happy with that? All right. So the other part of the question is, find the points on the parabola when t equals plus or minus 2. Okay, all we have to do now is just sub in. This is where parameters are really, really helpful, okay? So if we want to find the x and y values when t is plus or minus 2, we can't do it with that form because there's no t, but we know that x equals 2at, and we know that x equals, and y equals, sorry, at squared, so we can just sub the value t equals 2 in, okay? So if you have a look here, we've got when t equals 2, x equals 4 times 2, because it's 4t. Does that make sense? So when t equals 2, we just sub it in there, and there's our answer. When t equals minus 2, we can sub it in, and there's our answer as well. And we can do the same thing for y. Just sub plus 2 in, minus 2 in for y as well. Okay, so we've got our 2 points. All right? Here's the next part. You could be asked to find the coordinates of the focus and the equation of the directrix, okay, of the parabola. Okay. Now, this just relates back to our locus definitions. Okay. So what we want to do is we want to get the value for a, don't we? If we get the a in the x squared equals 4ay, if we get the a, then we'll be able to work out what the focal length is. We'll know the directrix and we'll know everything. Okay. So I'm not going to teach you method 1. I'm going to teach you method 2. So have a look here. We've got x equals minus 12t, but we know that x equals 2at. So that means that 2a equals minus 12, doesn't it? Which means that a equals minus 6. There we go, we've got the focal length already. Have a look at the answer. for method 2. Yep. We check, we know that it's an upside down parabola, so it's not minus 6, sorry, I got that wrong, didn't I? Yeah. So, just going back to our definitions, it's minus 12t and minus 6t squared. So gentlemen, what matters is, as long as you find the A, whatever method you choose, you can then quickly find out the directrix, the focal length, the vertex, you can find the focus and all those things, okay? Here's the last one. This last one is actually writing it as a set of parametric equations. So what you're given is the Cartesian form, or the locus form as we call it, x squared equals 32y, and we've got to write it as parametric equations, okay? So the way we do this is we know that the A value is 8, so we can quickly get that from x squared equals 4ay. Once we know the A value is 8, we know that this is a happy parabola, if you like, okay, because it's x squared equals 4ay. And so we know that for that happy parabola, if you like, x equals 2at and y equals at squared. So all we do is we just put in the value of A straight in to the two parameters. Is that okay? And so you just end up with x equals 16t and y equals 8t squared. That's it. That's all that's required there. Same thing there. Find out the A, put it into the parameters. Standard forms, okay? 11.8, do them all.